Good afternoon, E-Techians. This is Mr. Lake, and this is your lecture for the assignment today, which is assignment 3, reading resistors. And so this is what I'd like you to do. This is the book. Let me zoom all the way out. And this is that NCCER book, and it's on page 10 of the second or third chapter. I don't know, you'll find it. When you see all these electrical symbols like this, that's what you'll need. And here's what I want you to do. I want you to take notes on 7.00 resistors. Just take those notes, kind of like what we did last time, but it's not very much. Just going to read this. And I want you to read this and this. And through here. And then you stop when you get to 8.0.0. Now this resistor color codes is what the main activity is going to be on. So just read page 10, 7.00. 7.1.0, and then stop when you get here. Okay, and then what I want you to do is I want you to, in your notebooks, I want you to, and this is all part of the same assignment, so outline that reading, and then I want you to copy this chart into your notebooks, and I'll get some color pens so that you can, and I want it in color. These different stripes on the resistors, you can read those stripes, and based on the color you can figure out what the resistance is to the resistors. And so I want you to basically copy this chart and use color pens to get those copied in there. Okay, and then what I want you to do is to make a chart 1 through 20, and here's some resistors right here. Let me zoom in. Come on now. So here are some resistors, and I'll bring them up so you can see them right there. These are resistors, and what they do in a circuit is they restrict the flow of current. And so let's say you have a battery. Now I've been drawing batteries like battery. Well, let's see. Let me show you. Here's like a C battery, right? And then we take our wire and we hook it up, and here's our Christmas tree light. And we hook it up over here. Maybe you're using aluminum foil as the wires. So here's the little light bulb, and it gives off light. So anyway, so it's a Christmas tree light. Now this is kind of awkward to draw every time, so we have symbols to represent batteries and things that use the energy in the battery, resistive elements. So here's the symbol we're going to use for a battery, and here's the symbol we're going to use for a resistor. So this is our battery, E. It has a voltage of E, and here's our resistor, R, and this sends a current through the circuit, I. And remember Ohm's law. Ohm's law says that E equals I times R. We talked about that before. But also, actually, I like to think of it, this is the way we always write Ohm's law, but this is the way I like to think of it. R equals E over I. That is, the resistance in a circuit is how much voltage, the voltage you need to get 1 amp of current to flow. So this is volts per amp, and a volt per amp is equal to an ohm. Okay, and so now light bulbs are, you can think of a light bulb as being a resistor. It constricts the flow. It controls the flow of how much current will flow in there, and also it does something with the energy. In this case, it makes heat and light. Now these kinds of resistors, which you break open any electrical piece of equipment, a cell phone, or if you bust open like an old VHS player or whatever, you're going to find these things in there. They're called resistors. And all they do is turn the electrical energy into heat. And this is why electrical equipment gets hot. You know, it's because it's got lots of resistors in it, because it has to control the current that flows in it. And so it has a symbol, a zigzaggy symbol like that. One thing you can think about when you make a circuit is that if you're, like, let's say you're the electricity and you're in this wire right here. When you're in this wire, you have zero energy when you're down here. But then when you go through the battery, you get energy. Now how much energy you get depends on the battery. Like if I have two 1.5 volt cells, I will get 1.5 plus 1.5. I would get 3 volts, or 3 joules of energy per coulomb of charge. And then when I go around the circuit, that's how much energy I deliver to my resistor. So it'll deliver 3 joules of energy per coulomb of charge that moves through it. So with a battery, the energy goes in to the electricity. The electricity carries the energy over to my resistor, and the resistor takes the energy out of the electricity, and it does something. It makes a motor turn, or it just heats up. These kind of resistors just heat up. Okay. So read the book, make an outline as I explained, and then what I want you to do, and your substitute teacher, Mr. Stanley, will pass these out, and you will have to use these little color bands to figure out what the resistance is of each resistor. There are 20 of them, and you can work together, try to figure out what the colors are and what the resistance in ohms of all of these are. And so get as much done on this as you can today, and then we'll go over it tomorrow. That is all.